In this video, we start the study of particle kinematics. We will start with the simplest topic, rectilinear continuous motion of a particle. But before that, I'd like to briefly introduce the general definition of position, velocity, and acceleration. If you recall from the statics course, the position of a particle can be represented by the position vector. To do that, we need to first establish a reference coordinate system. In this case, a 3D XYZ rectangular coordinate system. The particle now has coordinates of XYZ, and the position of the particle is represented by a vector r that is drawn from the origin to this particle. This position vector r is written in Cartesian form as xi plus yj plus zk. Here, I, j, k are the unit vectors along the x, y, z axes respectively. As long as there's motion within the same coordinate system, position is a function of time. So after some time, this particle has moved to a new location with new coordinates x prime, y prime, and z prime, and its position is now represented by a new position vector r prime. The change in position of this particle, which is r prime minus r, is defined as the displacement. As you can see, displacement is also a vector. Velocity is defined as the rate of change in the object's position. From calculus, we know that it is the time derivative function of position. Acceleration is defined as the rate of change in the object's velocity, so it is the time derivative of velocity or the second derivative of position. Note that both velocity and acceleration are vectors and functions of time. Now let's look at rectilinear continuous motion. Rectilinear means that the path of motion is a straight line. So again, we want to set up a coordinate system so we can describe the positions of the particle using position vectors. But since it is a rectilinear motion, we can simply set up a one-dimensional axis along the path, choose the origin to be a convenient point, and represent the positions using vectors drawn from the origin, S1, S2, etc. Since here S is a vector, negative S indicates a position in the opposite direction to the origin. Once again, the position S is a function of time. Here, continuous motion means that the position function st consists of only one equation, versus later on when we discuss erratic motion, that is when the position function is a piecewise function that consists of multiple equations. From time t1 to time t2, the average velocity is defined as the change in position over the change in time, delta s, or the displacement over delta t. When the time difference, delta t, approaches 0, the average velocity becomes the instantaneous velocity, defined as ds over dt, or the time derivative of position. Sometimes we also use the word speed, which means the magnitude of velocity, and it has no sense of direction and is always non-negative. Another scalar quantity we sometimes use is distance traveled, st. It is the length of the actual path traveled, and it is not the same as displacement. For example, if this ball travels 5 meters to the right and returns to its original position all in 5 seconds, since there is no change in the position of the ball, its displacement is 0, therefore its average velocity is also 0. However, its distance traveled is a total of 10 meters, and therefore its average speed is 10 meters over 5 seconds, which is 2 meters per second. Now please answer the following questions.